Okay, so we've got this curve with this equation, y equals integral of 2 to e to the x of 5 times t take 2 to the 4 dt. Okay, so the first part of the question says, use calculus to find the equation of the tangent to the curve at the point 0, minus 1. Okay, so just a quick sketch here says, here's the point 0, minus 1. The curve kind of goes through that point. Don't really know what it looks like. It may not be even a turning point there. Let's assume it's not. But here's a tangent. Okay, so we need to find that formula. Remember, the formula for the tangent is y equals mx plus c. Okay, so we're going to end up with an answer that looks like this format here. So the first thing is the m. The m is simply the gradient, or which is the slope, which is the first derivative. Okay, so the first thing we have to do is figure out dy dx. Okay, so dy dx, so this is using the fundamental theorem of calculus, which just says that if we've got the integral of a function and then differentiate it, you're going to get back the original function. So in this case, it's 5 times, now we're just going to be careful of the way we do this, because e to the x is the power, so it's e to the x minus 2 to the 4, and then we use the chain rule to differentiate e to the x, which gives us e to the x. Okay, so that's dy dx. That function there, I guess we could simplify by bringing the e to the x out the front, but we don't have to do that. And what we know is that it goes through this point here, which is 0, minus 1. So when x equals 0, y equals minus 1, and dy dx, because we can plug 0 into here, equals what? So e to the 0, so let's leave the 5 there. E to the 0 is 1, minus 2 is minus 1, to the power of 4, times e to the 0, which is 1. Okay, and all of that comes to 5. Okay, so that's the m value. Okay, so the gradient is m. So that's our m value. Now we need to find out c. So we know that in the formula y equals mx plus c, that y equals minus 1 at this point where m equals, x equals 0, so c equals minus 1. So the formula for the gradient is y equals 5x minus 1. Okay, so the formula for the tangent. Okay, so now find the x-coordinate of the stationary point on this curve. Okay, so stationary point is when dy dx equals 0. Okay, so let's look at the function that we've got. So the function we've got is 5 times ex to the 2, take 2 to the 4, times e to the x, so that's this function up here. So the 5 can never be a 0, the e to the x can never be a 0, so only this can be a 0. So the only way this is 0 is if this thing in the brackets is 0. So when e to the x equals 2. Okay, and then you can calculate that. So you end up with x equals approximately 0.693, okay, from a calculator. Okay, so now that's the dy dx equals 0, so that's the x-coordinate of the stationary point. So that's one answer. Oh, so it's part of the answer. The second part of the question says determine the nature of this point. So is it a min, is it a max, or is it an inflection point? And the way we do that is plug in values that are slightly bigger or slightly smaller and see what we get. We could also do it by taking the second derivative, but that maybe looks a little bit complicated in this case. So let's just do it by plugging in the values. So when x is a little bit less than 0.693, so let's say like 0.6, what are we going to get? In this function here, we know that e to the x here at exactly 6.93, or whatever the approximation is, that's going to be 0. So if it's a little bit less than that, then when we take that number and subtract 2, it's going to be 2, so with a little bit less, it's going to be less than 2, so it's going to be slightly negative, but we're raising it to the 4th power, so it's going to be positive. And then you're going to multiply by 5, which is also a positive number, and then you're going to multiply by e to the power, which is also a positive number, so that's going to be 0. So when x is slightly less, then dy dx is greater than 0. When x is slightly bigger than 0.693, so let's say it's like 0.7, then we've got e to the x minus 2, so this is going to be a little bit bigger now, and that's going to be a positive value. So slightly bigger than 2, so that's going to be positive. Raised to the power of 4 is going to be positive, multiply by a positive value here, multiply by a positive value here, you're still going to get a positive value there. Okay, so what happens when both of them are positive? That means that the function, so the function I've drawn it, as I've drawn it here, is actually wrong. It should be something like, where are we at? I won't try and make this exact, but it's here, because it's saying that the function has a positive gradient on this side and continues to have a positive gradient on this side. Therefore, that function with the x-coordinate of 0.693 is a horizontal inflection point.